Hello everyone, welcome to this new video. So in my previous videos I had discussed two problems related to convolution theorem. So hope you have watched that video. So in this video we are going to solve two more problems related to the convolution theorem only. Okay. So again these problems are very easy and very simple. Just if you know the integration very well, so you could be scoring marks easily. Okay. So one question is confirmed from this topic. Okay. So whatever I'm doing in this video, right, all the problems are very important ones. Okay, so those have not seen those previous videos, please go and watch it. Let us continue with the problem now. Next question is L inverse of 1 divided by s cube into s square plus 1. Okay, you should be finding its convolution theorem. So here f of s is equal to 1 divided by s cube into s square plus 1. So this you could be splitting and writing it as 1 by s cube into 1 by s square plus 1, right? So which is here it is f of s and this is g of s, right? So now our L inverse of 1 divided by s cube into s square plus 1 is equal to L inverse of 1 by s cube 1 by s square plus 1. Okay, where here f of s is equal to 1 by s cube and g of s is equal to 1 by s square plus 1, right? So here now, in order to find f of u, we need to be knowing the value of f of t. F of t is given as L inverse of f of s. So f of t is equal to L inverse of 1 by s cube. Okay, so we know that L inverse of 1 by s to the power n plus 1 is given by t to the power n by n factorial, right? So here in place of n plus 1 we are having 3. Okay, so if we substitute the value of 3 we could be writing it as 2 plus 1. Okay, because here n plus 1 is equal to 3, equate the degrees, so n would be equal to 3 minus 1, that is n equal to 2. Okay, so here we could be splitting this and writing it as 2 plus 1. So here the value of n is 2, so this would be written as f of t is equal to t square by 2 factorial, that is 2 itself. Okay, so our value of f of u, what it would be, u square by 2. Okay, similarly find the value of g of t. G of t is given by L inverse of g of s. Okay, g of t is equal to L inverse of 1 divided by s square plus 1. Okay, 1 divided by s square plus a square. So L inverse of 1 divided by s square plus a square is given by sine at divided by a. Okay, but here in place of a we are having 1, so our g of t would be equal to sine t by 1 or sine t. Okay, so our g of t minus u would be becoming equal to sine of t minus u. Okay, so now our integration, how it would be looking like, L inverse of 1 by s cube into s square plus 1 is equal to integration from 0 to t f of u into g of t minus u du, right? So f of u it is u square by 2 and g of t minus u is sine of t minus u du. Oh, so now here 1 by 2 we can take it common outside, integration from 0 to t u square sine of t minus u du. Okay, so here if you observe, under the integration the two different functions or two different terms are getting multiplied, so you should be applying integration by parts here. Okay, so most of you might be knowing what is integration by parts. So those who don't know, I'm going to tell you. Integration of by parts means multiplication of integration with respect to ue, that is this is equal to, how it is calculated, that is first function u into the integration of second function minus integration of integrated function, that is whatever after integration what we have got, we should be again integrating. So integration of integrated function into differentiation of first function, that is d by du of u into du. Okay, so this is the formula for integration by parts. So according to this, we are going to consider this as u and this as v and further solving it. Okay, let us see what we will be getting. So now 1 by 2 into first term is u square, so u square as it is, into integration of second term sine of t minus u, okay, minus integration of integrated that term, that is sine of t minus u, into the differentiation of first term, that is u square du. Okay, so now let us simplify and see what we will be getting. 1 by 2 into u square into integration of sine of t minus u, that is integration of sine is minus cos, so what we will be getting, minus cos t minus u divided by coefficient of u. Coefficient of u is minus 1. Okay, minus integration of this term here, that is minus cos t minus u divided by minus 1. Okay, that is minus minus, you cancel it out, so you would be left with cos t minus u, right? D by du u square du. So simplify again, step by step I am doing. Okay, observe carefully. So u square and minus minus goes, so we are left with cos t minus u minus integrate this term again, or else keep it as it is and differentiate this term, differentiation of d by du with respect to u, right? So u square differentiation is 2u du. Okay, so that is 1 by 2 u square cos t minus u minus, here 2 is there, right? That you take outside, so you are left with you write first u cos t minus u du. So again here if you observe here this part, again these two terms are different terms, they are getting multiplied again, right? So again for this part again you should be using the integration by parts. Okay, so further solve it as it is. So now this term don't go to touch, for the rest of the steps keep it as it is, that is u square cos of t minus u minus 2 into, now for this part apply the integration by parts, that is first term integration of second term, that is cos of t minus u minus integration of integrated term, that is cos of t minus u, into the differentiation of first term, that is u with respect to u. Okay, so now solve it. 1 by 2 u square cos t minus u minus 2 into u and integrate this term. Integration of cos is sine of t minus u divided by coefficient of u, that is minus 1. Okay, then what we have, minus integration of whatever integrated term we got, that is this term, minus 1 we have, so minus sine of t minus u, and differentiation of d by du with respect to u, that is differentiation of u is 1. Okay, so that you don't write and directly write du, that is 1 by 2 u square cos t minus u minus 2 into minus u sin t minus u minus of integration of sine. Integration of sine is minus cos, but we already have minus sine, so it would be plus cos. Okay, cos t minus u divided by the coefficient of u, that is minus 1. Okay, so like this we have got. Now solve it, simplify again. U square cos t minus u minus 2 minus u sin t minus u, and here minus divided by minus is plus cos t minus u. Okay, don't forget to put the limits here in all the cases, 0 to t. Okay, limits are from 0 to t. Okay, 1 by 2 u square cos t minus u minus into minus plus 2u sin t minus u minus plus minus 2 cos t minus u. Limits are from 0 to t. Okay, now apply the limits for this whatever we have simplified, that is 1 by 2 into t square cos of t minus t plus 2t sin of t minus t minus 2 cos t minus t minus the lower limit, that is 0 square cos t minus 0, that is 0 itself, minus 2 into 0, so again it is 0, minus 2 cos t minus 0, that is t itself. Okay, so we are left with t minus t is 0, so t square cos 0 sin 0 and cos 0. Cos 0 is 1, so we are left with only t square. 2t into sin 0, sin 0 is 0, so this term goes, and again minus 2 cos 0 is 1, so minus 2, then minus into minus is plus 2 cos t. Okay, so this is our required final answer. So like this you should be simplifying this problem. Okay, so this is our final answer, note it down. So we have one more problem, let us quickly solve it. So this is the next question. L inverse of s divided by s square plus 9 into s plus 2. Okay, so this is the final problem. Let us see what we will be getting as our answer. Okay, so here f of s is s divided by s square plus 9 s plus 2. So this again could be written as s divided by s square plus 9, introduce 1 divided by s plus 2. Okay, so L inverse of f of s is equal to L inverse of s by s square plus 9 1 by s plus 2, where the new value of f of s is s by s square plus 9 and g of s is 1 by s plus 2. So in order to get the value of f of u, we should be finding f of t. F of t is L inverse of f of s. So f of t is equal to L inverse of s divided by s square plus 9. Okay, so this is of the form L inverse of s divided by s square plus a square. Okay, so that is equal to cos at. So in place of a we are having 9 here, so 9 could be written as 3 square, so our value of a is 3, so f of t would be equal to cos 3t So therefore f of u, you will be getting it as cos 3u. Okay. So similarly for g of t, in order to find g of t minus u, we need to know g of t, that is L inverse of g of s. So g of t is equal to L inverse of 1 divided by s plus 2. So again this is of the form L inverse of 1 divided by s plus a, that is equal to e to the power minus at, right? So g of t is equal to e to the power minus, in place of a we are having 2, so e to the power minus 2t. So g of t minus u is equal to e to the power minus 2 t minus u. So this is the value of g of t minus u. So now finally do the integration part, that is L inverse of s by s square plus 9 into s plus 2 is equal to integration from 0 to t. F of u is cos 3u, g of t minus u is e to the power minus 2 t minus u du. Okay. So do the integration now. 0 to t cos 3u e to the power minus 2t, and minus into minus is plus, e to the power 2u du. Okay. So here if you observe carefully, e to the power minus 2t, you could be taking it as constant because we are doing this whole integration with respect to u, right? So here we are getting one t term. So what I am doing is e to the power minus 2t I have taken constant here, 0 to t cos 3u e to the power 2u du. Okay. So now this you could be rewriting it as e to the power minus 2t integration from 0 to t e to the power 2u cos 3u du. Okay. So if you observe here, this is of the form, we have one formula for this kind of integration, that is integration e to the power at cos bt is given by e to the power at divided by a square plus b square into a cos bt plus b sin bt, right? So according to this, now take its integration. So this would be now e to the power minus 2t into, in place of a what we are having, 2u. So here now it is with respect to t, but we are doing with respect to u. So in place of a we are having 2. Okay. So e to the power 2u divided by a square, that is 2 square, plus b we are having 3 square, into a cos bt, that is 2 cos 3u plus 3 sin 3u. Okay. Limits are from 0 to t. So now e to the power minus 2t, 2 square plus 3 square, 2 square is 4, 3 square is 9, 9 plus 4 is 13, you take it out constant here. Okay. E to the power 2u, 2 cos 3u plus 3 sin 3, 0 to t. Okay. Apply the limits now. E to the power 2t, 2 cos 3t plus 3 sin 3t minus the lower limit, that is e to the power 2 into 0, 2 cos 3 into u, that is 0, minus plus 3 sin 0. So sin 0 is 0, so that goes. So here e to the power 2t, I'll take it outside here, divide by 13. So we are left with 2 cos 3t plus 3 sin 3t. So e to the power 0 is 1, so this goes. So minus this goes, so cos 0 is equal to 1, so minus 2 remains. Okay, so e to the power minus 2t into e to the power 2t, so the power base is same, powers get added, so minus 2t plus 2t, so that is e to the power 0, 2 cos 3t plus 3 sin 3t minus 2. So therefore what is e to the power 0? E to the power 0 is 1, therefore our answer is 2 cos 3t plus 3 sin 3t minus 2 the whole divided by 30. So this is our final value of f of t. Okay, so like this the problems are based on convolution theorem. Okay, so we have completed the convolution theorem part. So we have left with only one topic now, applications to solve the ordinary differential equations using the Laplace transform. Okay, so that we are going to solve using inverse Laplace transform and using partial fraction method. Okay, so let us see that those problems are the finale of this module, and those problems are very lengthy ones. So let us see how to solve it. Okay, that's all. Thank you.